So in this video we're going to go over calculating the distance between 2 points in three-dimensional space. So if we have 2 points in three-dimensional space, the idea is if we consider the first point x naught, y naught, z naught, and the second point in three-dimensional space x1, y1, z1, so 2 arbitrary points, and we want to know the distance between those points. The idea is that if we construct a right triangle in three-dimensional space, we can find the coordinates of this point right here. This point will have the same x and y coordinates as the points above, because we're just dropping a perpendicular from this point towards the xy plane. So we're dropping a point either up or down to the xy plane. So if we just kind of, without loss of generality, consider dropping it down, then we're going to get a right triangle if we pull this line out parallel to the xy plane. And the coordinates on this point are going to be x1, y1. They're going to match the coordinates above, but they'll be at the same height as z naught for this point. So we get coordinates x1, y1, z naught. And at some point, either above or below, if you're in the xy plane, you would have x1, y1, and 0, and if we drop perpendicular to the xy plane here, we'd have the point x naught, y naught, 0. So this is just a point in the xy plane, and the idea is the distance from here to here is going to be the same as the distance from here to here. And we know how to calculate the distance between 2 points in the xy plane. We know that the distance between 2 points is just the square root of the sum of the squares of the difference between the x coordinates by the Pythagorean theorem and the distance between the y coordinates. So this is just an application of the Pythagorean theorem. Some books like to call this the distance formula. I just like to say, hey, this is the Pythagorean theorem in action. And that means this distance here, because the distance from here to here, which is directly below this point here, and this point is directly below this point here, then this distance is just going to be this distance d. And then you can use the fact that the distance between these 2 points is going to be the absolute value of the difference between the z components. So the z is giving the height. So z1 minus z naught will give a directed distance, and we take the absolute value in case it's negative. So if we want to know the length of the line segment from here to here, let's give it a name r for right now. Or if this is point P and this is point Q, then if we want to know the distance from P to Q, then that distance by the Pythagorean theorem is going to be r squared equals, and I have a right triangle, so it's going to be d squared, the distance across the base of that right triangle. It's going to be d squared plus the absolute value of z1 minus z naught. So z sub 1 minus z naught, and we square that, and if we're squaring it, we don't need the absolute value sign. And so ultimately we replace d squared with, well, d squared would be take the square of both sides here, which is just going to give you the stuff on the inside, the x1 minus x naught quantity squared, plus the y1 minus y naught quantity squared, plus here you're going to get z1 minus z naught quantity squared, where we get to drop the absolute value like I mentioned because of the squaring. So this would be the square of that radius or distance from P to Q, and if you needed to know the distance itself, you would just take the square root of both sides. So I like to think of this as a Pythagorean theorem in three-dimensional space, and this box right here formalizes that result, so something that you can put in your notes. So if we apply this in practice, it says find the distance between these 2 points. I like to draw a 2D representation of it. I don't worry about graphing them by hand in three-dimensional space. I just say, hey, here's a two-dimensional representation of what's going on in 3D. Here's my 2 points. I want to know the length of this line segment, and we then just apply the Pythagorean theorem in three-dimensional space, we say, hey, the distance is going to be equal to the square root of the sum of the squares of the differences between the x, y, and z coordinates. So the x coordinate is going to be 2 minus negative 2. The difference between the y coordinate is going to be negative 5 minus 3. And the difference between the z coordinate is going to be negative 2 minus 2. And then we just simplify. The square root of 2 minus negative 2 is 2, squared is 4. Minus 5 minus 3 is minus 8, squared is 64. Minus 2 squared is 4. And then this is going to be equal to 64 and 4 is 68, and that's going to be a 72. And 72 is the same as what? 9 times 8, which is the same as 9 times 4 times 2. So we're going to get the square root of 9 is 3, the square root of 4 is 2, 3 times 2 is 6 times the square root of 2 in simplified radical form. That's the distance between the 2 points.